This is an air disaster. That's not an accident. The worst part is that this is not going to be the only one. There are more to come because it turns out that these tragedies have something in common. The biggest air disasters in history all started with one thing in common. They all began with a pitch problem. If you're a pilot or flight attendant, you probably already know what we're talking about. But for everyone else, this may come as a surprise. So let's take a moment to explain this simple aviation term that has caused so many deaths. Believe it or not, pitch is one of the easiest concepts in aviation to understand. It's simply the angle at which an aircraft is pointed relative to the horizon. If you're flying level, then your pitch is 0 degrees. If you're climbing, then your pitch will be somewhere between 0 and 30 degrees. And if you're descending, then your pitch will be somewhere between -3 and -90 degrees. In other words, pitch is how steep an aircraft is pointing. Of course, it's important to remember that pitch is relative. An aircraft can be pitched up or down, but it's always relative to the wings. Level flight means that the wings are parallel to the ground. A positive pitch means that the aircraft is pointed up, while a negative pitch means that the aircraft is pointed down. So what could possibly go wrong? Well, as with everything in aviation, it all comes down to maintaining control. You see, when an airplane is flying straight and level, there is a balance of forces acting on it. As long as these forces are equal, the plane will continue to fly safely. However, if any of these forces become unbalanced, then the plane may stall and crash. In the case of pitch, the most dangerous situation occurs when the nose of the plane points too far up or too far down. Let's start with a nose-up situation. When the nose of an airplane is pointed to high, it creates an imbalance of forces that can cause the plane to stall and crash. This is because when the nose is pointed up, the airspeed over the wings decreases, which reduces the amount of lift generated by the wings. If the plane's nose is pointed too far up, then the lift generated by the wings may not be enough to keep the plane in the air, causing it to stall and crash. Nose-up situations are relatively rare in commercial aviation. One notable example was British Airways Flight 029, which crashed in 1974 due to a number of factors, including a nose-up situation. However, this type of crash is more common in general aviation. For example, a small plane may nose up during takeoff if the pilot is too aggressive with the controls, or a plane may nose up during landing if the pilot is not properly managing their speed and altitude. On the other hand, a nose-down situation presents an entirely different set of challenges. When the nose of an airplane is pointed too far down, it creates a different imbalance of forces that can also cause the plane to stall and crash. In this case, the airspeed over the wings increases, which generates more lift than the wings can handle, causing them to stall. This can happen if the pilot accidentally pushes the nose of the plane down too hard, or if the plane is in a high-speed descent. Nose-down situations are relatively more common in commercial aviation than nose-up situations. In fact, some of the deadliest crashes in history were caused by a nose-down situation. Take, for example, Turkish Airlines, Flight 1950, which crashed in 1963 after a period of turbulence caused the nose to drop, or Japan Airlines Flight 100, which crashed in 1985 after a faulty repair caused the rear of the plane to separate, pitching the aircraft up and then down. However, in modern commercial aviation, there is another factor that can contribute to a nose-down situation, and that is wind. Wind shear is a sudden change in wind speed and direction, and it can occur at low altitudes, such as during takeoff or landing. When an aircraft encounters wind shear, it can cause the nose of the plane to drop, reducing the angle of attack and potentially leading to a stall. In fact, wind shear was a contributing factor in the crash of United Airlines Flight 232 in 1989, which resulted in 275 fatalities. Now, before we get into the details of some of the deadliest crashes in history, here's a quick reminder that while pitch is an important concept to understand, it's just one piece of a much larger puzzle. Aviation is a complex field, and every aspect of flight, from takeoff to landing, involves a multitude of variables that must be considered. Pitch is simply one variable among many that pilots must monitor and control to ensure a safe flight. That said, understanding pitch is crucial for anyone involved in aviation, whether you're a pilot, flight attendant, or just someone who wants to learn more about how planes work. Now let us take a look at some of the deadliest crashes in history and see how pitch played a role. Up first is the Cockpit Airlines Flight 129 accident, which occurred in China in 1994. This accident was caused by a nose-down situation during takeoff. On September 26, 1994, a Boeing 737-200 was performing a non-precision approach to runway 24 at Jiaoqi Airport. The pilots had requested an instrument approach to runway 24, but due to poor weather conditions, the airport controller decided to vector the plane away from the runway. The controller cleared the plane for a visual approach, and the pilots initiated the approach. However, they failed to recognize that the runway was wet and that there was a strong tailwind component. The pilots also failed to adjust the thrust levers to the takeoff position and selected full flaps. As they advanced the throttle, the plane surged, indicating that it was close to stalling. The captain pushed down on the control yoke to prevent the plane from stalling. But as the plane accelerated, the nose dropped and the plane ran through its approach. The plane went through the approach lights and overran the end of the runway. It then descended through a forest and hit a highway where it broke up and burst into flames. All 128 people on board were killed. Next up is the Aviation Airlines Flight 5, which happened in Uzbekistan in 1999. This crash was also caused by a nose-down situation during takeoff. On March 6, 1999, a Tu-154 was taking off from Tashkent International Airport. When it encountered a wind shear event, the wind shear caused the nose of the plane to drop, which resulted in an aerodynamic stall. The pilots were unable to recover the plane, and it crashed. All 178 people on board were killed. Another deadly crash was the Kazan Airlines Flight 112 crash, which happened in Russia in 2013. Again, this was caused by a nose-down situation during takeoff. On December 5, a Sukhoi Superjet 100 was performing a nighttime takeoff from Kazan International Airport when it encountered a wind shear event. The wind shear caused the nose of the plane to drop, which resulted in an aerodynamic stall. The pilots tried to recover the plane, but they were unsuccessful. The plane crashed and broke up in mid-air. All 136 people on board were killed. Finally, we have the DHL Flight 6098 crash, which happened in Belgium in 2003. This was the first crash in history to be caused by a nose-up situation. On February 7th, an MD-11 was attempting a low-visibility approach to runway 23 at Brussels Airport. The plane was under the control of a flight simulator as it approached the runway. As the plane got closer to the runway, the flight simulator commanded the pilots to pull back power on engine No. 3. After engine No. 3 was put on idle, the aircraft started to pitch up and the flight data recorder showed a pitch rate of 7 degrees per second. At 21:24, the nose of the aircraft pitched up to 27 degrees and the aircraft stalled. At 21:25, the aircraft impacted terrain at a very steep dive angle. Both pilots and one flight attendant were killed. So, why does pitch matter? Well, it matters because when an airplane stalls, it loses all of its lift and falls from the sky. That's what happened in all of the accidents we just discussed. In each case, the plane lost lift and fell to the ground, resulting in a deadly crash. But why should you care? Well, because it could happen again. There is no guarantee that the mistakes that cause these crashes won't happen again in the future. Human error is always a possibility, and even the smallest mistake can have deadly consequences. That's why it's so important for pilots and flight attendants to be well trained and to always be aware of the risks involved in flying. The smallest mistake can have devastating consequences. One of the best ways to honor the victims of these crashes is to learn from their mistakes. By understanding the causes of these crashes, we can work to prevent them from happening again. So if you're interested in learning more about aviation safety, we highly encourage you to check out our other videos. We've covered a wide range of topics, from the causes of other types of crashes to the best practices for pilots and flight attendants. Thank you for watching this episode of Air Crash Investigation. If you enjoyed the video, please don't forget to subscribe to our channel to catch new episodes every week. Also, if you want to support our team of researchers and editors, please consider supporting us. Your contributions help us continue producing quality documentaries for you. Thanks again for watching, and we'll see you next time.